Hi, welcome to Key Skill 5. We're going to be looking at a new formula. I think everyone is sick of the nth term formula by now. And we're going to be looking at how to add up sequences really quickly. So for example, here we've been given 7, 14, 28, and we've been asked to add it up for 5 terms. So what would that actually look like if we were going to do it manually? So 7, 14, 28. You'd want to keep working out the next 2 terms because they've asked you for what the first 5 terms are added together. So you can work them out. So now you have all 5 terms. The sum of the first 5 terms would be 7 plus 14 plus 28 plus 56 plus 112. So let's type it all in. And you get S5 is 217. However, luckily for you, there is a much faster way to do this. And what we need to do is go back to our Excel formula booklet. And it's here. The SN, S stands for sum, which means adding up, formula is given A, 1 minus R to the N, divided by 1 minus R. I will add a little star asterisk that this formula is only okay if R is between -1 and 1. If you have an R that's bigger than 1, it's much better for you to swap the R and the 1 around, both inside the bracket and on the denominator, and use this formula here. So if we go back to our example, we need to identify A, the first term, A is 7. Identify R, okay, well, each time we're multiplying by 2, so R is 2. And then we need to say how many terms do they want. They want the first 5 terms, so N is 5. And we need to calculate S5. So we start by writing down our formula. We select the formula where the R is first and the 1 is second because our R is 2, so that's bigger than 1. Now we substitute everywhere. So A is 7, R is 2, and N is 5. We can cancel this down a little bit by saying 2 minus 1 is 1, so when the denominator is 1, it just basically disappears, so you don't really need to write it anymore. So we can type this inside our calculator, and we get that S5 is 217. This is much faster than working out what all of the terms would be and then adding them together. Imagine if you're asked to find S20. You wouldn't want to work this out 20 times. So this is much more efficient. In question 2, we've been told that A is 5 and R is a quarter, and to find S6. Now we're going to use the smaller version. We're going to use the version of the formula where R is small. So we're going to flip around the 1 and the R. So now we can substitute inside. A is 5. We want to find S6, so we know that N is 6. 1 minus a quarter to the power of 6. And here 1 minus a quarter. Now be careful, that N is on the R, it's not outside the bracket. That's something I sometimes see students doing. They do 1 minus a quarter, and then they put that power 6. No, the power 6 is on the quarter itself. You want to type all of that in. The best way to make sure you don't make that mistake is to put your R in brackets and put the 6 on the outside. Et voila! We've been asked to find this to the nearest number. So 6.6 to the nearest number would be 7 because it's closer, it is approximately, it's closer to 7 than it is to 6. So again, using the 1 minus R formula for small r's, r's less than 1, and the R minus 1 if R is bigger or bigger than 1. If you have specifically a sequence that is decreasing, so your R has to be a fraction or a number less than 1, you have the formula for S infinity, because your sequence can go on forever and ever and ever. It's not exactly, you can't exactly work out what the sequence would be if you added it up for an infinite amount of times, because that's impossible. At a certain stage, the terms in your sequence become so tiny that we take the limit. We imagine what it is when those terms basically become so close to zero, we just imagine that they are zero. So here we start again. We take the A is 4. We take the R, well, we do 1 divided by 4. We can check a quarter divided by 1 is a quarter. 1 over 16 divided by 1 over 4, quarter. And in this case, we want S infinity. So we're going to use this formula here. A divided by 1 minus R. And you can see this condition here is that R is less than 1. So write out your formula. Here our A was 4. 1 minus a quarter for the R. Now, to work this out, we can change the 1 into 4 over 4 so that we have a common denominator. 4 minus 1 is 3, 3 over 4. In this situation, you take the bottom number of the 3 and multiply up with the top number. Or if you imagine you had 4 over 1 divided by 3 over 4, and then you flip the second fraction. So our answer then is 16 over 3 for the sum to infinity. If you're interested to see how this formula works, we can just take a second to look at that. The formula for Sn is 1 minus r to the power of n, 1 minus r. Now, if your sequence is decreasing, like ours, you can see from 4 to 1 to a quarter to a 16th, there will get a point where your r powered with n will be so tiny that it's practically 0. So if I imagine what this formula would be with such a teeny tiny r, it would be a times by 1 minus 0, 1 minus r. And 1 minus 0 is 1, so it would be a times by 1, which is just a. And you can see that this is happening here already. This formula started on 0, but by the time it already gets to 1 over 16, you've got a tiny number. And in a few iterations, so if I times this one by a quarter, I have an even smaller number and a smaller number. So this sequence will go so infinitely small that it will practically be 0. Let's have a look at question 4. We've been given a sequence and we've been asked to find the sum of terms from n is equal to 4 to n is equal to 8. So for example, if we can imagine here, that's 30, that's 3, that's 30, that's 300. Each time we're timesing by 10, so the next one will be 3,000, for example. We've been asked to find the sum from the 4th one to the 8th one. So let's imagine what that looks like if we were to draw it. We've got 1, 2, 3, 4, 5, 6, 7th, and the 8th term. So this is the 1st, the 2nd, the 3rd, the 4th, etc. Now they want from 4 to 8. So they want all of these ones added up. They want to add the 4th one to the 5th one, to the 6th one, to the 7th one, to the 8th one. Now, the problem is the sum formula cannot be adjusted like that. The sum formula always starts from 1. Imagine it starts counting. So what we can actually do to get around this is we can say, I'm going to do the sum of 8 terms. So that would give me this one, this one, this one, all of these added together. And I'm going to subtract the sum to 3 terms because I don't want the first 3 terms added together. So if I do the sum to 8, it will add together to me term 1, term 2, term 3, all the way up to 8. So it's really useful to think, what is S8? S8 is U1 added with U2, the first term added with the second term, added with the third one, all the way up, and we keep adding until we've added up all of the first 8 terms. Then we want to subtract S3 because we want to subtract the first term added with the second term added with the third term. Because what will that give us left? U1 take away U1, that will be gone. U2 take away U2, and U3 take away U3. That will leave us left with U4 plus U5 plus U6 plus U7 plus U8, or it will leave us with the terms from the 4th term up to the 8th term. So let's calculate S8. So A is 3 and R is 10. Let's write that down. So here I need to put my 3 and here my 10. And 10 minus 1 is 9. S8. I'm going to just cancel down here as well, actually. So 10 to the 8 minus 1 divided by 3. S8 is going to be lots of 3s. 1, 2, 3, 4, 5, 6, 7, 8. Okay, we're going to do the same method for S3. We're going to get 3. Now it will be 10 to the 3 minus 1 over 10 minus 1. S3 is 3. 10 to the 3 minus 1 over 9. And again, you can cancel down here. So what's S3? 10 to the power of 3 minus 1 over 3. 3, 3, 3. So S8 minus S3 will be this one minus this one. So 1, 2. You don't really need a calculator, but if you're feeling a bit lazy. 1. That means if I added up, starting adding up from the 4th term, I added the 4th to the 5th to the 6th to the 7th to the 8th. I added up those 5. I would have a number with a lot of 3s. I think we can leave it at that. Okay, let's have a look at our last question, question 5. A little bit tricky. The sum of the first 4 terms is 3 times the sum of the first 2 terms. What that means is that the sum of the first 4 terms is equal to 3 times the sum of the first 2 terms. Now, people get confused about where to put the times by 2, and you have to think, how can I make them equal? If the sum of the first 4, if S4 is 3 times bigger than S2, so imagine, for example, S4 is 6 and S2 is 2. If I want to make them even, I need to times by S2 by 3. I need to increase S2 by a factor of 3 to make them the same. So what I do now is I write the formulas in for both of them. For the n here, I'm going to put a 1. Now, what I want to do is just cancel that down. I can take off the denominators from both sides because they are the same. I can also have a little, whilst I'm cancelling like a crazy person, take off the a's. That leaves me with r to the 4 minus 1 is equal to 3r squared minus 1. I can actually break this down further using the difference of 2 squares. The difference of 2 squares is a squared minus b squared is equal to a minus b, a plus b, and I can use it here. If I imagine that r to the 4 is r squared minus 1 squared. So if I make a r squared, and that double squared, squared will make the 4. So this will factorize to be r squared minus 1, r squared plus 1 equals 3 r squared minus 1. I can cancel this on both sides now. And I've got r squared plus 1 is equal to 3. R squared is equal to 3 minus 1. R squared is equal to 2. And I take the square root to find r as square root 2. That brings us to the end of Key Skill 5 and lots of tips and tricks about how to deal with questions with the sum of the geometric sequence. Later in the course, we're going to be getting into more worded questions, things with finance, depreciation, and compound interest. So stick around for that. Bye for now.